Now, for those that have some kind of experience in cold-in-place recycling, mixed design, quality control, quality assurance, now the next speaker, Steve Cross, professor of the School of Civil and Environmental Engineering for Oklahoma State, and also is a technical director of the Asphalt Recycling and Reclaiming Association. Please welcome.
I represent the Asphalt Recycling and Reclaiming Association. I think a lot of you that are still here probably know who we are, but a few of you that don't, our website, www.erra.org. But we're a contractors association and supplier association. We represent 4 industry segments: cold planing, hot in place recycling, cold recycling, which we break down into cold in place recycling and cold central plant recycling. There's actually a lot of interest with cold central plant recycling these days. And then full depth reclamation. So you might be wondering, why are we here? Well, you don't think of these things in pavement preservation. Well, this is a chart we got from Federal Highway Administration a few years ago. Pavement preservation falls into the maintenance categories of preventative, routine, and corrective. And according to the feds, hot in place recycling and cold recycling fall under preventative and corrective maintenance. So you can use your pavement preservation funds for these activities. But we can also add some structural overlays, make these things significantly stronger, and get into the structural overlay and a major rehab. And then FDR obviously does not fall into the pavement preservation. You've seen the curves lots of times, so I thought I would slap this up here just to show you, pavement preservation is done early in the pavement life. As it starts to deteriorate a little bit more, we tend to get into hot in place recycling. Hot in place recycling can treat anywhere from about 1 to 2 inches down into the pavement structure. You get into cold recycling, 3 to 4 is typical. We can go 5 inches under some instances. And full depth reclamation, I've seen them go 2 foot in 2 passes, but there's a lot of people, it's usually 8 to 12 is a little more typical. So one of the things I got asked to talk about was curing. So if we're talking about curing, I made the assumption that we're talking about cold in place recycling. We usually don't have issues with curing with hot in place recycling. So when I'm working with cold in place recycling, I have 2 different recycling agents I can use. I can use foam or expanded asphalt, or I can use emulsified asphalts. And really curing, to simplify it, is getting the water completely out of the system. It's a little more complex than that, but that's kind of a start. So how does this water get in there? Well, you got to put water on your cutting teeth, okay? And typically that's anywhere from 2 to 2.5% moisture goes in. Now there are some new cutting tools out there that you can knock that water down to 0.5 to 1%, but they're not out there real well. So it's the same for both. There takes a little bit of water to foam the asphalt, but that's a very small amount, okay, not really all that significant. But there is water in the emulsified asphalt. It might be 1% by weight of the wrap from the water in the emulsion. With foam, you do usually end up adding a little bit of water for compaction. In fact, a lot of times you run a modified proctor to figure out what the optimum asphalt content is and make sure you have enough water in there for compaction. For an emulsified asphalt, we might add a little bit extra water to help disperse the emulsion, but we're not going to add water for compaction because usually we have plenty of water in there, okay? So then there's also water in the pavement. So with foamed asphalt, I'm sure you're all familiar with this, so I'm going to go through this rather quickly. We're going to add a small amount of water to hot asphalt, and that's the water's going to evaporate, turn to a gas, result in a lot of small droplets of asphalt, and these get dispersed throughout the mix. It's kind of like it's a binding technology. It's not a coating technology. And then a foamed asphalt project is going to gain a strength fairly quickly because as the asphalt droplets cool, their viscosity is going to go way up. They're going to gain strength rather quickly. So curing issues with foam you don't really run into that too often. But one of the keys with foam is you got to make sure that asphalt foams, because if it doesn't foam correctly, you're going to develop stringers or globules of asphalt in your mix, and instead of binding it together, you just put a lubricant in there. So it is very important in your quality control when you're doing this stuff that you check the half-life and expansion ratio in the field. Every time they bring a load out, there should be a test nozzle on there. Check it. Having the asphalt at the right temperature is a real key to getting proper foaming. So it's almost always got to be above about 320 degrees Fahrenheit, but it's got to stay below 375. Okay? And again, if you're not familiar, the expansion ratios, the volume of the foamed asphalt to the residual unfoamed asphalt, we really like to see a minimum of 8 times that expansion to get good dispersion and binding. Half-life, how long does it take to lose half the volume? We need about a minimum of 6 seconds. You know, so if you drop below that, you're liable to have trouble with globules and stringers and end up with a lubricant in there. But again, when the asphalt droplets cool, they've stuck the stuff together, curing is not that big of an issue. So we're going to move on to emulsions, and that's really the issue. I get real nervous talking about emulsions and emulsion chemistry, but a typical emulsion might have anywhere from 40 to 70% asphalt. They might put a little bit of polymer in there. Depending on the type, you could have up to 10% solvents. For cold-in-place recycling, cold central plant, we really recommend you stay away from the solvent-based emulsions. We like the solventless ones, although there are a few people that are still using them. The chemical package in there could be anywhere from 0.2 to 2.5%. Water anywhere from 30 to 50. One of the most common asphalts we'll use is basically a CSS1 or CSS1H. And you'll see about 60 to 65% asphalt, rest water, and a little bit of other, no solvent. So it's kind of funny when we talk about curing, are you talking about breaking, or are you talking about setting, or are you talking about curing? Okay, so we want my asphalt emulsion to break, okay? And then it's going to start curing. So there's several different mechanisms that will take place. So the emulsions have a charge on them. That keeps them dispersed, they have the same charge on them. So we can, the destruction of that charge by neutralization of an acid for cationic emulsions is one of the components. You've probably heard if you add lime or cement, it's going to break quicker on you. Why? You're putting a base in there. So you've destroyed that, you've neutralized that acid, so that'll speed up the brace. Also, you have a charge on that asphalt droplet, you have a charge on your aggregate or wrap property. It's going to pull it to the surface, and that's going to help it to break. And then finally, the curing is the evaporation of water. You got to get that water squeezed out of there. So 3 different mechanisms. One of the nice things about emulsions, and this was new to me, and I don't know what a homothetic contraction in bitumen emulsions is. This is somebody else's slide, but I liked it. But once that droplet charge is destroyed, those asphalt droplets are very strongly attracted to one another. So they will come together and form a continuous film. Okay? So, and they'll do that even if water is present. So that's actually, you know, a picture of a fully dispersed emulsion on the far left. And after 15 minutes, you can see where it's moved together and attracted itself to each other and pushed the water out. So what affects this stuff? There are some things that we can control. There's some things we can't control when it comes to how fast things are going to cure. The aggregate reactivity, or the RAP in this case, you know, has a big impact. The surface area, unfortunately, with cold-in-place recycling, the surface area is small. Surface charge has an impact. Surface chemistry. But you can see in there, you can add filler chemistry. You can put in a little cement or lime, and with a cationic emulsion, you can speed up that break and cure and really increase your early strength. The reactivity of the emulsion itself has an impact on this, and so this is where we start seeing the engineered emulsions. And you know, your suppliers will engineer their emulsions, change the emulsion chemistry or the concentration to get a controlled break. The one we have only a little bit of control over is temperature, humidity, and wind speed, because that's how the water is going to evaporate and get out of the system. Okay? So if you try to work with an emulsion on a cold, rainy, foggy day on a really wet pavement, it's not going to want to break and cure very quickly. And then compaction. The compaction will also mechanically squeeze water out from between those droplets and help it coat and start gaining strength. Now, as far as curing, it does take a while to develop full strength. It can take months to develop full strength, but as long as you get it to break when you want it to, it'll gain strength fairly rapidly. We did a survey for TERRA. You can get on TERRA's website and find this. Roger's gone, but did this for Roger a few months ago. We sent out a questionnaire, and one of them is the time/criteria when you place an overlay, an issue or concern with CIR and FDR. About 60% said yes. We had about 45 agencies respond, about 40% no. The one that surprised me, are you satisfied with your criteria? 75% said yes, 25% said no. What was the most common criteria? Moisture content. Measure the moisture content, okay? So, how do we measure curing? Well, right now, ERA is recommending a couple of things. We do want this to cure a minimum of 3 days. Whether it's foam or emulsion, we like to get some traffic on there that helps fully break the emulsion and get it really nice and cured. Allows you to gain some initial strength. With the traffic running over it, you get some extra densification. We also want the moisture content below 3%. Okay, but if your pavement was wet to begin with, or it rained on your pavement, you've added more water to the system. You're not measuring the water in the emulsion, you're measuring the total water, so we have some issues with that. So if the moisture content doesn't fall below 3%, we don't really want that thing left open more than about 10 days. And if the roadway's been free of rain for a minimum of 2 days, you're probably okay to overlay it, okay? Again, if the road's not stable, don't overlay it. Okay, but it really probably should be if you did the proper design and selection of materials. Problem is, moisture content's not always the best method. We would like to see a new method out there. There are some people looking at some things, and ERA is more than willing to help people evaluate these things. Because the problem is, it's not necessarily total moisture that affects breaking and curing. It's getting that moisture out of the emulsion, and you can only measure total moisture. But in a lot of cases, measuring moisture content does seem to work well. If you do this in the summertime, your pavements are relatively dry, you don't get rain on it, it actually works quite well. So, what to do? Well, don't cold recycle in cold, damp weather. We recommend a minimum of 40 degrees or 50 degrees Fahrenheit, depending upon where you are. Don't do this if heavy rain is imminent, Be careful with pavements with high in situ moisture contents. That may not be your best project to select, okay? Other thing I tell people when we hear about, the emulsion's not breaking and whatnot, there is a raveling test out there, and there's some issues with the raveling test, but run the raveling test. Run it at the right temperature, okay? And the right humidity, and it will give you a pretty good indication that under certain conditions your emulsion will break, okay? And we have some criteria on that we'll get to. If you're really concerned about getting a good break and early curing strength, consider the use of an additive, either cement or lime. We typically say no more than 1% cement or 1.5% lime. We want to keep that ratio of residual asphalt to cement greater than 3 to 1, because you don't want to turn a flexible system into a rigid system. It'll crack up on you. One of the other things we like to see people do, if it's been curing and the mix is still a little bit soft, before you put that overlay, come back and do secondary compaction. You can sometimes pick up 2 to 3 pounds of additional density doing that. That's not generally done with foam, just with emulsions. Okay, I've told you all I know about curing. So, real quick, one of the most common things we hear about these in-place recycling techniques is why we don't do it, is a lack of information on it. So, talk about some of the available resources that are out there real quick. How am I doing on time? Good, okay. We put out the basic asphalt recycling manual in 2001, and it was the book on in-place recycling. You see the original one. It's been translated into Chinese. I actually got the copy of that. It's been transferred into Spanish as well. So it's been all over the world. However, it was getting a little dated. There's been a lot of advancements in materials, construction equipment, etc. So a couple of years ago, we started work on revising the document. And at first, they thought it would be just a few slight changes. We actually rewrote the entire document. So it's a completely new one. It's the Basic Asphalt Recycling Manual, or the BARM. It came out late spring, early summer. Again, completely rewritten. It's divided into 6 parts. We have an introduction to recycling. We talk about cold planing, hot in place, cold recycling, full depth reclamation, and an appendix. And on each one of our cold place, hot in place, etc., we have basically 4 chapters. One on pre-construction activities or project selection, cover mix design, construction, and quality assurance, sampling, and testing. All right, but you know, we want that document. I wrote the first one, I wrote the second one, I'm not writing a third one. So I want this thing to stay around for a long time. So we decided to come up with some best practice guidelines, because things will change. There's some research out there. We can keep this current. So ERA has on their webpage a series of best practice guidelines for each one of these disciplines. And our 100 series is just recommended construction guidelines or best practices for construction. Our 200 series is recommended mix design guidelines. Our 300 series is recommended quality control. Some of these are developed, some aren't quite ready. The 400 series is project selection. We're starting work on that one. That's not out there yet. Where can you find these? Well, you can go to our webpage, and if you click on the tab that says resources and go all the way down, there's a tab that says guidelines, and you click on that and you can download these in PDF versions. If you don't want to do that, shoot me an email and I'll send them to you. If you want to buy the BARM, you can go under shop and you can find it there, and we'll sell you one there as well. All right, what else is available? We have either put together or in the process of putting together 3 web-based inspector training courses for cold in place, hot in place, and FDR. Cold in place has been out for about a year. You can find it on the TCCC webpage or the NHI webpage. That's the number. I have until Friday to review the final draft of the HIR before they're going to post it. And I'm getting the draft back from the consultant on the FDR in a week or so. So those other HAR should be out in the next month or so, FDR probably by the end of the year. And these are, unfortunately, these have gone over to AASHTO. They used to be free. They charge you to look at them now. Another thing that's out there, the NHI has a 2-day course on asphalt pavement in-place recycling techniques. It's NHI 131-050. Any state, federal, local agency, contractor, industry group can agree to host this class. There are 2 web-based introductory modules, and it's a 2-day instructor-led class. And it's geared for people that are selecting and designing recycling projects, writing specifications, and inspections. Very good course. But along with that, I guess earlier this spring, Virginia Tech had me come out and help them put on a 1-day seminar for Wisconsin DOT. We thought this went over really well, and we are in the process of developing and have some concentrated 1-day courses. We have one on cold planing that NCPP is working on, and ERA will put you together a hot in place, cold recycling, or full depth reclamation class. We'll come to you if your agency is interested in full depth reclamation or cold in place. It's hard to travel. We'll come up and put on a 1-day class for you. Typically cover project selection, mix design, thickness design, construction, and quality control. For the one we did in Wisconsin, we actually did cold and full depth for them. So we can kind of customize these to your liking. So finally, wrap this up. If you would like to get a copy of the BARM, the easiest way to get one is to see an ERA member. And if you're an agency, they will probably get you one. You can purchase one on the web. Go under that shop tab and you can purchase one on the web, or today and today only. Okay? I have been told I can sell you one of these at the member price, which is $60, and there's no shipping on it, and I'll take cash, check, or credit card if you will see me later. But honestly, that's going to save you about $32, I think, if you try to buy one off the web. So I have a few of these if you're interested. Would like, just let me know right after the meeting. So I see Pablo coming this way, and I'm done. So that's my contact information. It's steve.cross@okstate.edu. That's Oklahoma State University. That's not that other university down there. So again, if you're interested in any more information on this, give me a holler. Thank you very much.